Hello everyone, today I would like to cover an important data structure of programming language, and that is tree. And if I get enough time, then I would cover for you guys a specific version of the tree, and that is binary search tree. So we have a common view of the tree that we can see in the nature, jungles and forests, that we have a roots, branch and leaves. But the root is on the very bottom, then we have branches that connected different leaves together. But in a programming perspective language, that image is the reverse of the previous image. And we have a root on the very top, then we have a leaves, and we have branches that connected different leaves together. But here we see a new phrase that which is called nodes. That is a phrase that commonly used in order to explain the different leaf in the tree. Later on you can understand this terminology better as I go further more. So here is a picture of the hierarchical organization, which is an example of the real world usages of the tree. So you can see here, for example, you can first imagine your computer that you have a different directory, like directory C, D, E, and so on, depends on how you partition your computer. But like in this picture, we have on the very top as a root node my stuff, and then underneath of that we have a different directory that connected to the root node, that is school, play, work and home. And there are other directory that connected to those directory, and also it could be possible there is no other directory to those, which is like a new folder that you don't have any file in those. So that's how the computer organize and save different files, and how it's easier for the computer to understand, and how faster you can find those files and directory and images or whatever file that you try to save or use. And here we have a different tree terminology and phrases that we use in programming perspective language. So as mentioned, on the top we have a root node, then we have a direct edges that connected the different nodes together, and we have a leaf node, which means if a node that has no children is called a leaf node. And also we have a parents node, which is node 7 and 5 here, and node 5 is a parent node to node 9, and node 7 is a parent node to the 2 and 6. And other phrases and terminology we use in tree data structure programming, it is the ancestor, which is node 7 here is an ancestor to node 2, 6, 5 and 11 as the toppest node or the parents node to those other node that are underneath of that. And also we have the node we call sibling, that they are the nodes are in the same level. The different another terminology that we use often in data structure programming language are depth, level and the size. So the level that we can see here, we have a 4 level, but specific, it is very important that in programming we started from 0, and how here we represent it. We have on the very top a level 0 for the root node, then we have level 1, 2 and 3, and there is a different formula in order how you can find the levels of each tree rather than just counting or just like seeing the picture. But I wanted to explain you guys more about the different terminologies, so and later on we may cover those formula as well. So here I have one slide for you guys that you can pause the video and go and fit those terminology that I explain about the tree, like a node, a root, parents, ancestor, and different levels of a different tree. And let's go to the next slide. Here we have a binary search tree, but we don't have enough time. I would cover you guys just with a short explanation of them. And binary tree is a specific version of the tree that at max each node has 2 children, not more, not less. At max has 2 children and